and this is a point O. This is the center of this circle. So AP and BP, this is an angle over here. Let me just... Zen, please change your name in the meeting. Rename yourself. Okay. Now, Riaz, can you please tell me, uh, if I ask you angle subtended by chord AB, this is chord, okay, at point P. Can you please name that angle? Any of you, Riaz, Zen, whoever knows the answer. Okay, Riaz, you tell me. Angle subtended by the chord AB, this chord AB, at the point P. PT means it is short for point. Which angle is it? Can you name that angle, Riaz?
Uh,
Were you there in the previous class?
no, ma'am.
No. Why?
No, I was in another class. Like,
You were in another class. Which class were you in?
I was having extra classes, I mean.
Extra classes. Okay.
Yes, ma'am, for the
Were
exam.
you, okay. Were you there in the class before this? The last to last class, were you there? Were you there in any class of this chapter?
Yes, ma'am.
So that means you should know what this means. Angle subtended by chord. We have discussed about this in length. Were you paying attention when we were discussing this?
Yes, ma'am, like, but I don't remember.
Why do you not remember? I have to talk to your parents, okay? I will be talking to your parents soon. And then Zen, can you name the angle in this figure? Which angle is the angle subtended by the chord AB at point P? Yes. Zen, I'm asking you. When someone's speaking to you, at least unmute yourself.
AB or AP?
The question is written on the screen.
I don't remember, ma'am.
But you were there in the previous class, right?
Yes, ma'am.
What were you doing in the entire class? If you didn't understand the very basic thing which we have been discussing throughout this chapter, the very first thing which I told you guys in the beginning of this chapter, angle subtended by a chord. What does it mean? We discussed it in length, and then I told you what is the meaning of angle subtended by a chord. So if you didn't understand, why didn't you ask? Why didn't you raise a doubt? Please switch on your video first of all, Zen, and the rest of you also. Tell me. If you were not understanding something, why didn't you ask the teacher, ma'am, I didn't understand what is going on in this chapter? Because if you don't know what is the meaning of angle subtended by a chord, then you will not understand anything in the chapter. So that means you were not able to understand anything that was going on in the previous classes. And we have had about 5 classes of this chapter till now. So Zain, I have to speak to your parents also. Anyway, let's move forward. So the angle subtended by a chord, now listen carefully, okay? Angle subtended by a chord at any point means this angle over here. We said angle subtended by chord AB, this chord, this chord AB. Okay. Acha, what is the meaning of chord? Okay, I will give you a few line segments in this circle. Okay. Okay. So Zen, tell me one
Yes,
thing.
ma'am.
So this is AB. This one is AB, the horizontal one. This is PQ. This is OR. This is, let's say, EF. Can you tell me which one of these is a chord? There are two chords over here. In this particular diagram, there are two chords. Can you tell me which two of them are chords?
Uh, AB and QR.
AB and
Uh, OR.
OR is a chord. Acha.
Uh,
Then can you tell me which line segment over here is a radius? Can
so what?
you repeat?
Uh, uh,
Radius. I'm asking which one is a radius. Radius of the circle. This is something we have been studying since grade 6. Radius of circle, we know this. What is radius of circle? Over here, which line segment represents the radius of the circle? Zen.
AOB.
Okay. AO is radius, OB is radius, and one more. There is one more radius over here.
OR.
Good. Riyaz, what happened to your video? OR. So then OR is not a chord. OR is a radius. Okay. Listen to the definitions very carefully. Radius is that line segment which joins the center of the circle to any point on the circle. Over here, R is on the circle. So, which joins the center of the circle to any point on the circle. So, this is a radius. Similarly, AO is a radius. Similarly, OB is a radius. Okay. OR is not a chord. Why? Because chord is a line segment which joins not center and a point on the circle, but chord joins two different points on the circle. Okay. So over here, P is a point on the circle and Q is another point on the circle. So PQ is a chord. Okay. PQ is a chord. And similarly, AB is also a chord. It is a special type of chord which is called diameter. Diameter is the longest chord. Okay. If someone asks you, Riaz, you have to tell me this. Name the chord which passes through the center of the circle. Look at PQ. PQ is a chord, but it's not passing through the center. So can you tell me the name of the chord which passes through the center?
Diameter.
Very good. Diameter is the chord which passes through the center. So Zen, clear everything?
Yes, ma'am.
I am requesting you guys, if there's anything you don't understand, even if it's something very basic, please ask in the class. And if you're feeling shy to ask, you can message. You can send a direct message on the chat. Okay. So, so we have understood now what a chord means. This is a chord. So over here, this is chord. AB is a chord. Now, this statement is saying angle subtended by chord AB at point P means that look at the chord AB and it is making an angle at the point P. This point P. This angle is called angle APB, right? That's the name of this angle. Which angle are we talking about? Just a minute. We are talking about this angle. Angle APB. This one. This one. Understood? This is called the angle subtended by AB at point P. Okay, can you clearly see what it means? Angle subtended by chord AB at point P. Zen, Riaz, understood this?
Yes, ma'am.
Okay. Now,
Yes, ma'am.
there are a few more angles over here. Angle subtended by chord AB at point O. Can you tell me, which angle is it? Angle subtended by chord AB at point O, at the center of the circle, which is O. Which angle is it? Is it the pink angle or the green angle? Angle subtended by AB at the center.
The pink one.
Yeah, the pink one. In other words, it is angle angle AOB is called the angle subtended, meaning it's a different word, or it's a different way of saying the angle made by AB, the chord AB at the point O. Okay, so angle subtended, this is the word we use. So please remember it because you're going to use it throughout the chapter. Subtended by AB at point O. Similarly, Riyaz, can you tell me the name of the angle? The name of the angle subtended by AB at point Q. Can you tell me? The angle subtended by AB at point Q. Riyaz. Yes, Riyaz. Name of the angle subtended by AB at point Q. Abdul Jabbar, would you like to try? Name of the angle subtended by the chord AB at point Q. Then you can write the answer in the chat box. Yes, Abdul Jabbar. If you're unable to speak, you can write the answer in the chat box. No, then I will repeat the question. Angle subtended by AB at point Q. So look at the point Q and look at which angle is AB making over there. It's the green angle, right? And the green angle's name is what? AQB. Good. It is angle AQB. Okay. So anyway, let's move on to the topic for today's class. It is angle subtended by an arc. So till now we have seen angle subtended by a chord. Now we'll see what is angle subtended by an arc. So what is an arc? Basically any portion of the any portion of, just a minute. Uh, hmm. Any portion of the circle is called an arc. So, for example, from here to here, this portion is an arc. Okay. Or, for example, from here to here, this entire thing is an arc. So, if I say this is, let's say, this point is A, this point is B. And if I say angle subtended by arc AB, now there's no chord over here. There's no chord in the picture. There's only an arc. So angle subtended by the arc AB at the center is going to be this angle over here. This angle. This angle. Okay. So angle AOB is the angle subtended by arc AB at the center, which is O. Okay. And similarly, if I say angle subtended by arc AB at point P over here, then it's going to be this angle. Is this clear?
Yes,
What
ma'am.
does angle subtended by arc mean? So this is the angle. Now let's do a small activity, okay? Actually, there's no, I didn't want to do this activity if so many students are absent, but nonetheless, let me just share my screen in a minute. Okay, so I hope you can see my screen. There's a graph. Can you see it?
Yes, ma'am.
Okay. So I am just going to quickly make a circle. Where's the circle? Hmm, Wait a minute. Okay, there's some issue in this. Anyway, hmm. Okay, fine. I'm gonna share my screen again. I hope you can see it now. All right. So first we're gonna make a circle. I'm gonna make a circle over here. This is our circle. Now, what did we have? We had a chord. So I'm gonna take a chord over here. Not chord, sorry, arc. I'm gonna take an arc. So this is one point. This is another point. So this arc CD is an arc, right? The left one, the small one, CD is an arc. So this arc is going to subtend an angle at the center, and it's going to subtend an angle at the other point, which is B. So give me a minute. minute. Okay, now you can see the arc easily. Fine. You can see the arc. It's the red colored one.
Yes, ma'am.
Okay. Now this arc is going to subtend an angle at the center. The center, what is the name of the center over here? Who will tell me? What is the name of the center? Quickly.
A.
A. Good. So 1, 2, 3. So this angle over here is 106.3 degrees. Just a minute. Okay. This angle is 106.3 degrees. I'm just going to make this line segment so that you don't get confused. Okay. Now we are going to look at the angle subtended by it over here at any other point on the circle, which is point B. We're gonna measure this angle and see how much it is. It is, where did it go? Okay. Let me do one thing. Can you see that when I'm moving the point, both of these are getting changed? Can you see this? As I am moving this point, see, the size of the angle is also changing. But tell me one thing. This angle, both of these angles are changing. See, the angle CAD is also changing. The angle at the center, CAD, that is also changing, and the angle CBD is also changing. Can you see if there is a relationship between these two angles? Let me just show you one particular angle. Wait a minute. One. I'm not able to get an exact value. Okay. For example, take a look at this angle. The angle at the center, how much is it?
90 degree.
And angle at the other point, which is B, how much is it?
45 degree.
45. What is the relation between these two? What is the relation between these two? Yeah? Can you tell me what is the relation between 90 and 45? I'm not asking you something that I have taught you. It's something that you already know. 90 and 45. Yes, Riaz, you're trying to say something.
Ma'am, it's the half of.
Exactly. So 45 is half of 90, right? So we can see that the angle subtended by this arc, or it could be a chord, okay? The angle subtended at the center is double the angle subtended at any other point, and this is a very important result. And what if the point B was over here? What if I change the point B? Look, the angle at the center is still the same because it is still 45 degrees, right? What if I change, let me change this a little bit. Let me make it. Can you see that what is the angle at the center now?
100 degree.
100
And
degrees.
angle subtended by the arc, the red arc at point B is how much? At
50.
point B. 50 degrees. Again, can you
50
see that
degrees.
it is half of it? The angle
Yes,
subtended
ma'am.
at the other point is half of the angle subtended at the center. So this is a result which we are going to try to prove, that angle subtended by an arc, or by a chord for that matter, it doesn't matter. But the theorem says angle subtended by an arc at the center is double the angle subtended by it at any other point. So it doesn't matter if B is here or there or any other point, it is always double. Okay, so let's try to prove it. Just a minute, I will share my other screen now. Okay, fine. So the theorem, please note it down now. Theorem, it says angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. What does this mean? That this point P that we have written over here, it can't be over here. This point P can't be over here. It's not supposed to be here. It's supposed to be anywhere on the remaining part of the circle, apart from this arc, somewhere which is different from this arc. Okay. Abdul Jabbar, are you understanding?
Yes, ma'am.
Okay. You also please switch on your video, Abdul Jabbar. Okay, so let's do the proof of this theorem. Fine. So I'm just going to change the names of this. Okay. Now we, sorry, what is given? Given we have a circle with center O and PQ is an arc. The arc PQ subtends angle POQ at the center and angle PAQ at the point A on the remaining part of the circle. So we have to show that angle POQ is twice of angle PAQ. Okay. So we have to do a construction over here, and that construction is we have to join A and O. We have to join A and O. We have to join A and O and extend it to another point B. Any point it can be. Okay. So this is a construction. I'm just going to write it. Wait a minute. It's not even visible. So construction. Join AO and extend it to point B. Okay. So now let's look at triangle OAQ. Look at triangle OAQ. Which triangle am I talking about? Just a minute. I am talking about this triangle. This triangle. Okay. The yellow triangle. In triangle OAQ, we know that we know the exterior angle property, right? In triangle OAQ. Exterior angle property. What does it say? Can someone please tell me? What happened to all of your videos? Switch on your videos. I don't need to keep saying this throughout the class. Come on. Abdul Jabbar, please tell me what is exterior angle property? If you have a triangle, okay, and let's say this x is an exterior angle, the exterior angle property says, Zen,
Yes,
Zen,
ma'am.
what does the exterior angle property say?
Uh, the exterior angle of a given triangle equals to
Hmm.
the sum of opposite interior angle.
Okay, and where is your video? Exterior angle property says basically that the exterior angle, which over here is x. Exterior angle means that, see, a triangle has interior angles and exterior angles. This is an interior angle, means inside the triangle. This is also an interior angle inside the triangle, and this one is also an interior angle. We are talking about an exterior angle. X over here is an exterior angle. Similarly, over here also you will have an exterior angle, but we haven't drawn that because we are just concerned with this one, okay? So here exterior angle is angle x. Now this property says that x is equal to the sum of the interior opposite angles. Not this one. This one doesn't come under this property. The x is equal to the sum of the interior opposite angles, meaning the other two angles which are not adjacent to x. Okay, so a plus b. So this is basically what the exterior angle property says. So exterior angle property, if you try to apply it in this triangle, Abdul Jabbar, what will we get? Yes, Abdul Jabbar. When we apply exterior angle property to the yellow triangle, we will get that angle, this one, this angle over here, BOQ. Angle BOQ will be equal to angle this plus angle this. Angle OAQ plus angle AQO. Okay, so this is the first equation. And similarly, for the other triangle, this one, for the other triangle also we can say in triangle OAP, the exterior angle property implies that angle this one, BOP, is equal to angle OAP plus angle OAP plus angle this one, APO. APO. Second equation. Okay. Now, if you look at the triangle OAP, sorry, the triangle OAQ, from triangle OAQ, the yellow triangle. In triangle OAQ, we know that OA is equal to OQ. Can someone tell me why? Why is OA equal to OQ? Remember that this is a circle we are talking about. Isn't just some random triangle. Abdul Jabbar, please tell me, why are OA and OQ equal?
Radius.
Very good. So they are radii of the same circle. Of same circle. That's why they are equal. So since this is an isosceles triangle, it's an isosceles triangle, right? When two sides are equal, it becomes an isosceles triangle. So that's why we know this property of isosceles triangles, that angles opposite to equal sides are equal. So that means they are both going to be equal angles. So if let's say this is angle X, then this is also going to be angle X. So that implies angle OQ, what is this? A is equal to, or let's say angle AQO, this one, AQO, this one, is equal to this angle. So angle AQO is equal to angle OAQ. Okay. So if you apply this in the first equation, or let's do one thing instead of getting confused. Wait a minute. I'm just going to put both of these things over here. Okay. So also OA is equal to OQ, since they are radius of the same circle. That means AQO is equal to angle AOQ. Now, if you put that in equation 1, what will your equation 1 become? Abdul Jabbar, please tell me. Putting this in equation 1. Equation 1 becomes, let's say this is equal to X for the sake of convenience. Let's say this is equal to X. So equation 1 becomes, what is equation 1? Angle BOQ is equal to angle OAQ. What is OAQ? We have said it is equal to X. So equal to X plus angle AQO. This is also equal to X, right? Because they are both equal. So this is equal to 2X. Fine. Or in other words, we can say this is equal to twice of angle OAQ. This one. This is angle OAQ. Instead of X, I have just put OAQ. So let's do one thing. I'm just going to replace it. No need of writing X. Angle OAQ plus angle OAQ is equal to twice of angle OAQ. Okay. This is our equation number 2. Now similarly in the other triangle, triangle OAP, if at any point anyone is not able to understand anything, please ask, okay? Similarly, in triangle OAP, the other triangle, we have already seen that due to exterior angle property, this angle, the outside angle, is equal to the sum of this angle and this angle. So now these angles, again, they are going to be equal. Why? Because these two are equal. They are radii of the same circle. So they are both going to be equal. So again, what do we have? We have that angle, this one is equal to angle this one, meaning angle OPA is equal to angle OAP. So they are both equal. Since angle OPA is equal to angle OAP, OPA and OAP, isosceles triangle. Therefore, putting in equation 3, what do we get? We get angle BOP is equal to angle OAP plus angle, instead of APO, we are again going to write, instead of APO, which is this one, we are just going to write OAP. Okay, because they are both equal. So this is twice of angle OAP. This is equation number 4. Till here, has everyone understood everything? I need a yes or a no from every single one of you.
Yes, ma'am.
Okay. And what about the others?
Yes, sir.
Okay. And Abdul Jabbar? Sorry.
Yes, ma'am.
Okay. So when I ask you a question later on, you shouldn't say that I don't know this, because now you are saying that you have understood. Okay. So now what we do is, if we add these two equations, equation 2 and equation 4, let me highlight these two equations. Equation 2 and equation 4. Equation 2 says angle B, so angle equation 2 plus equation 4 we are going to do. Equation 2 says angle BOQ. So when we add two equations, what we do is we add the LHS to the LHS. We add the RHS to the RHS. So the LHS is this. We are going to add the LHS, angle BOQ plus angle BOP. And the RHS, we are going to ignore this part because this is not what we need. We need the last final thing which we have gotten. That is what we need. So twice of angle OAQ plus twice of angle OAP. So we can take 2 as common and we get angle OAQ plus angle OAP. Now can you look at this circle and tell me angle OAQ, which is this one. Angle OAQ plus angle OAP. Sorry. OAP. Can you tell me what is, when you add these two angles, which angle do you get? When you add these two angles, which angle do you get? Let me tell you which two angles I am talking about once again. I am talking about this blue line and this blue line and this blue line. Oops. These two angles I am talking about.
POQ and PAQ.
No, I'm asking again, listen very carefully. If you add this angle, angle PAO, PAO is this angle, and this angle, angle angle QAO. Which angle are you getting if you add these two angles? Think once again. Try. Try. Give it a try.
Reflection.
No. When we add these two angles, angle PAO, which is this one, and angle OAQ, which is this one, we get angle PAQ, this one. Angle PAQ, which is the angle subtended by the arc, the green arc over here, angle subtended by it on the point A. That is the angle we get. So when we add these two, we get angle PAQ. So twice of this thing plus this thing is angle PAQ. This angle over here. Angle subtended by the arc at the point A. And now, similarly, when you add BOQ and BOP, I want you guys to tell me the correct answer for this. Angle BOQ plus angle BOP. BOQ is this one. BOQ. Okay. Let me erase the other stuff. Angle BOQ is, okay. Angle BOQ is this one. You can see angle BOQ. And we have to add it to angle BOP, the pink angle which I'm drawing, which I'm marking, not drawing. When you add these two angles, which angle do you get?
Angle POQ.
Very good, Riaz. Angle POQ. So you get angle POQ. So using this method, by this proof, what have we shown? We have shown that angle POQ, which is this angle, the angle subtended by the arc at the center, is equal to twice of angle PAQ. Twice of angle PAQ, which is the angle subtended by the same arc at some other point of the circle, on the circle, right? So that is exactly what we had wanted to prove. See, we have written it over here. And this is what we wanted to show, that angle POQ, which is the angle subtended by the arc at the center, is double, double means twice of the angle subtended by it at any other point, which over here it was A. Is this proof clear to everyone? Any doubt in this? We can take a look at it again. Hmm? Any doubt in this?
No, ma'am.
Okay, please note down
No.
the theorem, the proof. Once you're done writing everything, tell me. We will move forward. Once you're done writing everything, and please don't forget to make the diagram.
I'm gonna scroll it down.
Yes, yes. Once you're done writing the entire thing, let me know. Hurry up. Zen, are you done?
Yes, ma'am.
Then why didn't you tell me that you're done? Riaz,
Wait, man, I'm doing one.
note down these questions for homework.
Done, ma'am.
Okay, note down these questions. Draw a circle. This is the center O. This is a point A, a point B. So AB is an arc. Okay. Then you have a point over here, P. So I'm going to connect AP and BP. And I'm going to connect AO and OB. So it is given to you that this angle over here is 100 degrees. You have to find angle APB. Okay, this is your question number 1. Then question number 2. Similarly, we have another triangle. The circle, sorry. So in the second question, this angle is given. Angle ACB is given as 40 degrees. You have to find angle AOB. Find angle AOB and angle OAB. OAB is this angle. Okay. So that's it for today's class. Are you done noting down the questions?
Yes, ma'am, done, ma'am.
Okay.
Okay, bye, ma'am.
Okay, bye.
Thank you.